Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about streams in Java. In this video I will explain what is streams, why stream exists, how a stream works, and what problem it solves. So if you are willing to learn streams in Java, then this video is for you. So make sure to watch this video till the end, and without wasting any time, let's get started. Alright guys, so let's begin this video. In order to understand stream, let me take you back in time when there was no stream API in Java. So when stream API was not available in Java, we used to write code like this. So let's imagine a problem. We have a list of cities and we need to compute the total population living in cities that have more than 100k inhabitants. Now how are we going to solve this problem? So it's pretty simple. We are going to run a loop to visit all the cities, then we are going to get the population of each cities, then we are going to put a if condition that if the population is greater than 100,000, then store the population into a sum variable. And this is how we are going to compute total population of the cities that have more than 100k inhabitants. If you run the program, we will get the desired output, that is equal to 1500,000. Okay, so far so clear. So this is how we used to solve problem when there was no stream API in Java. So guys, if you look at this algorithm carefully, in this algorithm we are specifically doing three operations. Okay, the first operation is the getting the population of the cities. Okay, so this operation we can refer to as a map operation. Why I am calling map? Because we are not interested in a city object, rather we are interested in a population of city. So we are basically mapping cities to its population. That is why I am calling this operation as map operation. And the second operation we are performing in this algorithm is filter operation. So you can see that we are using a if statement to filter all the cities which has population more than 100,000. Okay, so this is our filter operation, so we can refer it as a filter. And the third thing we are doing in this algorithm is reducing the population to a sum value. Okay, so we are doing a sum of population of all the cities which has inhabitants greater than 100k. So we can refer this step as a reduce step because we are reducing the population to a one value. Okay, so guys, if you look at this algorithm carefully, it turns out that we end up writing map filter reduce algorithm. And why I am calling this map filter reduce algorithm? Because we are mapping here, then we are filtering here, and then we are reducing here. That is why this algorithm is nothing but a map filter reduce algorithm. And this type of programming style is called imperative style of programming. And why I am calling imperative style of programming? Because in imperative style of programming, we explicitly describe each step to the program. So in case of map, we are describing that how to map object with the value. Then in case of filter, we are describing that how are you going to filter all the cities. And in case of reduce, we are describing that how to count the sum of population by declaring a sum variable and then storing all the population in a sum variable. So when we describe all the steps in program, then we call it as an imperative style of programming. Now let me show you one example of declarative way of programming. So here it is a MySQL query. Okay, so let's imagine that we have a database. In that database we have a table with the name cities, and in that table we have one column population. So if we had to compute the same result using MySQL, then how are we going to write the query to find the exact same result? It is pretty simple. We have to write select some population from cities where population is greater than 100,000. So here you will see that in this query we are again doing three things: map, filter and reduce. We are getting a column that is population, and the filter criteria is population greater than 100,000, and the reduce operation is sum of population. So sum of population is a reduce operation which aggregates all the population into one variable. Okay, but guys, do you see the difference between this style of code and this style of code? This is an imperative style of code while this is a declarative style of code. Now what is the difference between imperative and declarative? Here in imperative we are explicitly describing how to do a map, how to filter and how to reduce. But here we are not at all describing that how are you going to map the value, how are you going to filter and how are you going to reduce. So all of these internal complications is managed by the MySQL itself. Our task is just to define that what results we want, and it will do rest of the thing for us. But here, apart from describing what we want, we have to also tell that how this algorithm is going to compute that result. That is why this style of programming is called imperative programming, and this type of programming is called declarative programming. Okay, now guys, I hope this is clear to you. If this is clear to you, then we can move ahead to understand what are the problems with imperative style of code. So let me discuss the first problem with this code. First of all, this piece of code is not at all readable as compared to this piece of code. Here you can easily read that what we are doing. We are selecting sum of population from cities where population is greater than 100,000. But this is not the same case with this piece of code. Here it has a lot of code and it is difficult to read. Now the second problem of imperative style of programming is it is not expressive as this piece of code. Here you can see that this is not at all expressive, and if you see here, it is more expressive. We can express what we want to achieve or what we want to process, right? So this is the second problem. Now third problem is, in this program, as all the code is maintained by us, we are leaving very less space for JVM to do some optimization over this code. But this is not the same case with this declarative style of code. Here we are leaving room for MySQL to do any sort of optimization, right? It is up to MySQL that how it's going to fetch the cities, how it's going to filter the cities, and how it's going to map the cities. It is not up to us, it is up to MySQL. So here we have just defined that what we want to achieve, and rest all other things are performed by the SQL on behalf of us. But here we are expressing that what we want to achieve, and apart from it we are also expressing how are we going to achieve that thing. So this is the major difference between imperative and declarative type of programming, and I have explained that what are the three disadvantages of imperative style of coding over declarative style of coding. Okay, so now I hope that you understood what is meant by imperative and declarative style of coding. Now this brings us to the next question, that do we have any sort of mechanism to write declarative style of coding in Java? Well, this is where Streams API comes into picture. Using Stream API, we can write declarative style of code to solve any problem. Now let me show you the Stream equivalent of this piece of code. Alright, now you can see that this is a Stream equivalent of this piece of code. Here we have cities, then we are converting it into stream, then we are mapping, we are filtering, and then we are reducing. We are exactly doing the three operations what we were doing here. Now the question over here is that what is stream? So guys, stream has many definitions. It has not one specific definition. So let me tell you all the definition one by one. So first of all, we can say that stream is a companion framework of the collection framework. And why is it companion framework? Because collection framework help us in storing and accessing a data, while stream framework help us in processing that data. Okay, so this was the first definition of a stream. Now the second definition of a stream is a sequence of element from a source that supports data processing operation. Okay, so you can see here over is we are attaching a stream to this cities object, and using these we are getting a sequence of elements, and then we are performing all the operations on that stream. Okay, so this was the second definition. Now the third definition of a stream is an object that does not store any data, but the stream object is connected with a source, and from that source it pulls out one element at a time, pass through all the operation pipeline, and give us a desired result. And this is what happening here, that so we are converting this collection of cities into a stream. Okay, it's going to pull out one city at a time. It will pass one city through all the pipeline of operations and compute the result and store it in a sum variable. So these are the three different definitions of a stream. Okay, I hope you got it. Now the question arises that how this piece of code actually going to run, and how a stream is going to solve one of those three problems, that is this code is not readable, not expressive, and leave less space to JVM for optimization. So first let's understand how this piece of code is going to run. Okay, so guys, stream has two components. One is the intermediate operations and one is termination operation. So here first of all we have a collection of cities, and this cities is nothing but a source of a stream. Okay, as I said in definition that stream is an object that does not contain any data but that object is connected with a source. So cities is acting as a source here. Then by calling stream on cities, we are converting this collection into a stream. And what is a stream? A stream is a sequence of elements. So till here we are getting sequence of elements. And now we are adding intermediate operations to this stream. And that is, first we are doing a map because we are not interested in a city object, rather we are interested in a city.getPopulation value, right? And then based on that population, we are filtering all the objects of cities. Okay, and the criteria is given as lambda expression, and it is get me all the cities whose population is greater than 100,000. Okay, so these two are the intermediate operation. Now the last operation, reduce operation, is the termination operation, and this operation has nothing but integer dot sum value, and this sum is an aggregator function. So it aggregates all the population, computes the sum of all the population, and return it to the sum variable. So this is how, using streams, we can write declarative style of code. Now, do you know one cool thing about stream? That in a stream, without adding the termination operations, the intermediate operation is not going to process any data. This means till this intermediate operation, it's not going to process any data in this stream. As soon as we add the termination operation into this stream, then it's going to process all the data one by one. Now, how it's going to process all the data one by one? It's going to access all the data just like we did using a for loop. But here we do not care about the for loop because streams internally uses internal iterator to loop over all the elements. So how it's going to work? It takes one city at a time. It passes that city through all of these pipelines of operations and compute the result. Then again it's going to take the second city from this list of cities, pass through all the pipelines of operations and use it to compute a result. And this is how it's going to take all the cities one by one, pass through all the pipeline of operations and then compute the result. So this is how a stream is going to run under the hood. So now let's talk about the three problems which we were facing using this code. So now the first problem is solved by stream, that now the code is more readable. You can see that you can easily read this code. We are mapping here, we are filtering, and then we are reducing. The second problem is using the stream we have written a more expressive code. Okay, so we just have to express what we want. Rest all of the things is maintained internally by streams. So here we are expressing that we want a city whose population is greater than 100,000 and do a sum of all the population. That's it. This is what we are expressing. But here we are expressing in a more imperative way, right? Now the third problem which is solved by stream is, now using streams we are leaving some room or all the room to JVM to make some optimization over this code. As we are not handling the internal details, that how it's going to map or how it's going to filter or how it's going to sum, it's up to JVM to do any sort of optimization over this piece of code. So this is how all the three problems are solved by stream. So guys, in the last, I would say that there are two special goals of Stream API. Number one is, using Stream API, we can write readable and more expressive code. And using API, we give JVM some room to optimize our computation. And this is what it is done over here. So guys, I hope now you have good understanding of what is Stream, why it exists, how it works, and what problem it solves. So this is all from my side for this video. If you learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.